Assalamu alaikum and good afternoon everyone. My name is SM Sefat. I'm from University of Pendidikan Sultan Idris, Malaysia. So my model named ExplainNet. So I'd like to present to you this model. So why it's called ExplainNet? Because it's giving us the visual and linguistic explanation. So for what? For human-centered autism diagnosis. So you can ask me that why we really need this kind of model. To understand and to understand this, we have to understand why interpretability really matters in AI diagnosis. So for autism spectrum disorder, we need early diagnosis because it happens mostly on child, and there is a lot of methods like behavioral assessment, but it takes a lot of time. So for that reason, scientists are trying to build models like using deep learning models by using facial images, brain images, behavioral tracking. But there is one gap for every model. That is the black box. They are black box model. We don't really know what's really going on inside the model. We just know the decision giving by the model. Because the model is really complex, we don't really know why AI is giving us such kind of decision. So that is the first barrier to implement deep learning model to the clinical sector. So in the next slide, I'm trying to explain about the research gap. First of all, I would like to present accuracy and interpretability trade-off. So when the interpretability becoming lower, because accuracy becoming higher. Why? Because when accuracy becoming higher, the model is becoming more complex. So that's why interpretability becoming lower. For the models such as linear regression, decision tree, they are really interpretable. We really can understand why the model is giving the decision. It's interpretable by design. But the deep learning models are really not interpretable because they are complex. There is a millions of layers underneath them, so we don't really know why the model is giving us the decision. So accuracy is becoming higher and higher for each study, but there is less interpretable model. So scientists are trying to use some methods like RADCAM to understand why the model is giving such decision, where is the region of interest. As you can see in the picture, the heat map is providing the insights that model is focusing on this region. But we need an expert or we need a person to understand that why the model giving us this kind of decision. But we need something which is not this kind of heat maps, which will be also a clinicians friendly. So what is the first thing? We didn't find any hybrid visual plus test framework where there will be also a heat map from GradCam or other model, and it will be also generate a textual explanation so that a person can easily understand why is this happening. So we'd like to present to you ExplainNet framework. So how the model's uh, internal framework is working. First of all, we're giving an input image. To, and then to focusing on region of interest, we are doing image preprocessing, and we're also doing image augmentation to increase the generalizability like brightness comparison, contrast, or flipping. This kind of things we are doing. After that, we will make a dataset based on augmented and preprocessed ASD images. Then we will train it to a deep learning model. So in here we have explained about exception and efficient net, because from other studies we have found these two models as having very higher accuracy. But in our pilot study for computational efficiency and to make it lightweight, we are using MobileNet V2. So from there we will generate the GradCam heat map. And from the GradCam, we will understand the region of interest of the facial images. And the GradCam will provide us the region of interest, but we don't really know where GradCam is focusing most. We can just see some blurry images, but we will use facial landmark based region segmentation. So this will be done by two things. First of all is MTCNN, another one is DLIP. First, MTCNN will detect the face, and DLIP will segment it in different facial landmarks. And after that, we will make it through a transformer model. So in the transformer model, it will generate a human readable text. So it will show us where the model is focusing on. The model is focusing on mouth and eye region. that it will show. So, as you can ask me, where have you tried the model's feasibility? So yes, we have tried a pilot study where we have used very small dataset, which is 100 Kaggle images. So there is a risk of overfitting because of this kind of small images. So we have went through different augmented methods and different approach to increase the generability of the model. To make it lightweight, we have used MobileNet V2, and as you can see, the overall accuracy in 80%, which is not that good amount for facial image for autism diagnosis, but it's a promising one for the dataset like 100 images, and there is 100 images, and there is other performance metrics such as precision, FS score, and recall. You can see it's quite balanced. It's shown in the bar chart. So as you can say that 80% accuracy is not big amount for clinical, but it's the first start and it's really promising because the dataset size is really small. So in the pilot study, there is explainability map. So as we already described, we have generated the salience heat map, and we make an overlap with the facial images with the generated heat map. And after that, MTCNN detects the facial region, the which region from the GradCam heat maps. And after that, the DLEEP is segments 68 facial landmarks, but here we just for computational efficiency we are just using four main regions like eyes, nose, mouth, and forehead. And for lightweight we are using the rule-based mapping, and as you can see, it can give us the explanation of the model, where model is looking at. So we implemented through Google Colab, and also used PyTorch, and we used uh, a user interface called Streamlit. As you can see, we have also demonstrated a prototype that is we have made it through Streamlit. So as you can see, if you upload the picture, it will show us the prediction with the confidence score, and also will generate a text where the model is focused on, and you can also see the where is there is a heat map where it's focusing on. And after that, so what is the strength of our work? So we have validated an end-to-end pipeline, like image, heat map, segmentation, and text, and we made a correct region interpretation, like the meaningful ASD test. So we have also made a prototype, which is giving us a real-time explainability, and there is a balanced recall, and also for ASD and non-ASD for both, we have found that. But there is a challenge because the accuracy is 80%, which is below benchmark model. Because in ExceptionNet and the ResNet there is accuracy more than 95%, but the reason behind that is the dataset is really small, and our goal is to show the explainability of the model first. And the small dataset has overfitting risk, but there is a augmentation techniques that are applied, but it's not really sufficient enough. And there is also misclassification occurred in some facial images. There it's focusing on region of interest, but there is a there is misclassification occur. We have figured out that this is the reason because of the dataset diversity and the image quality. And therefore, proof of concept, we have restricted the explanation to the four regions. So the future work should be with to larger and diverse dataset, and have to implement the transformer based explanation and expanded facial region analysis, because in here we have used MTCNN and ELO, but for expanded work we have to focus on more like ELO landmark detectors, and we have to in the future work we have to show that the clinical researchers have to show the clinical workflow integration, that how this model can be implemented to the decision making, and we have to validate with clinicians, because without clinicians it's not possible to make this model successful. So in conclusion, what we did, we have made ExplainNet. We have proposed ExplainNet, which is a bridges the accuracy and interpretability, and we have demonstrated end-to-end pipeline, which is really explainable, like image to text. And the pilot study validated the feasibility and meaningful region-based explanation. And this is the more importantly, this is for to provide the foundation of clinically and trustworthy AI. So thank you everyone. If you have any question, I would like to accept the question. Thank you everyone. Thank you for your time. Assalamu alaikum.